Hi, Math 12. So we'll look at the first topic, which is the unit we're going to be looking at is function transformations. And so the first topic is going to be on horizontal and vertical translation. So basically what we're looking at is taking an existing function, so whatever that function may be, like the first thing we see here is a parabola, and then when we say we're translating it, what we're doing is we're moving it either horizontally or vertically. Okay, and so let's say you've got a normal function first that's not translated, and we want to move it. So look at this part here. Okay, so let's go through what this represents. So fx is your original function. So let's say your original function is y equals fx. Okay, and so here what you have, I think in your textbook it's written in this format, but you could also write it this way, y equals fx minus h plus k. Okay, so what you have here is h and k. Okay, so that's sort of been added in. And so what these are, h is takes care of moving the function horizontally, so either left or right, and k looks at moving the function vertically. Okay, so up or down. So let's look at the example here where you've got your original function, so let's call this one here fx. Okay, so that's your original function, y equals x squared. Okay, so that's just a parabola. Okay, so now what you see with the new parabola, it's been shifted to the right and it's also gone downward. So now the thing you have to look at in the bracket here, you notice how it's a minus sign. So whatever the sign is, it's actually the opposite that's occurring. Okay, so here's your new function here that's been translated. Okay, so when we say translation, we're talking about moving left or right and up and down. So you see how it says x minus 2 squared minus 1. So it's minus 2, but you go with the opposite of that. And so here, h is going to be positive 2. Okay, so that's always the opposite. So positive 2 means that you're moving, it's moving to the right. And then k is going to be negative 1. Okay, because it's going down 1 unit. Now, notice how some of the coordinates are also given. Okay, so let's call this function we'll just call it gx. Okay, so one thing that we're gonna application that we're gonna be using is called mapping. Okay, and so what you do in mapping is you take coordinates from the original function, okay, which is fx, and then what you do is you show how those original coordinates have changed onto the translated function. So here we call that gx. Okay, so for example, if we look at an original point here, right there, 0, 0, okay, the new coordinate for that is going to be 2, negative 1. Okay, so this is what we do when we're doing mapping. We take an original coordinate and we show how it's been changed. Now the new coordinates, another term that your textbook uses for this is called an image point. Okay, so that's called an image point. And you can do that with other coordinates as well. For example, you've got a coordinate over here, negative 1, 1. And so that's been, you can map that one to 1, 0. Okay, and so what you notice here, if we can keep using an endless amount of coordinates, what you notice here is basically your original coordinate, xy, is the pattern here is that your x coordinate keeps going to the right by 2, so x plus 2, and your y coordinate keeps decreasing by 1. So that's sort of the pattern that exists between the original function and the new translated function. Okay, let's look at another example here. Okay, so it doesn't matter what type of function you're looking at. So we just finished looking at a parabola. Now we can look at an absolute value. So remember, this is the absolute value symbol. Okay, so your original function here is going to be y equals, or fx equals the absolute value of x. So that's kind of like a base function. So remember what absolute value, the function of absolute value is it takes whatever's inside there and it makes it positive. So if it's like -2, it becomes +2. So when you're graphing this absolute value of x, if you want, you can use a table of values, right? So if you want to use a table of values, remember how you do that. You just basically make up an x value and then you substitute that into the absolute value to get the y value. So if x is 1, y is going to be 1. If x is -1, that's also going to be 1, and so on. Okay, so basically what you end up getting, let's blow this up a bit, you're going to get, here's your original function. Okay, so this is your fx. Okay, and then your new function. So here's what you're doing to your new function is here's the equation. Okay, so y plus 5 equals fx minus 2. So let's change that so that we're using the absolute value notation. And so what this is basically saying, so I'll rewrite it this way. So y equals absolute value of x minus 2. Okay, so that's a translation 2 units to the right, and then minus 5, which means it's going to go down 5 units. So again, what we can do is we can use the mapping. So let's say I'll use a different color here. Let's say we start with this 0, 0. So what's going to happen here is x is going to go to the right 2, so that's going to be 2, and y is going to go down 5, so that'll be 2 and -5. Okay, and so what you can do now is you can go to 2 and -5, and you can put a coordinate here. Okay, and then 1, 1, that's going to be, again, going to the right 1, so that'll be 3, going to the right 2, sorry, so that'll be 3, and then going down 5, so that'll be -4. Okay, so 3 and -4. Okay, and then here you're going to go to the right 2, so that'll be 1, and then this will be -4 as well. Okay, and so there's your translated function. Okay, and you can use more coordinates that I use there, right? So when you're doing this mapping technique, use as many coordinates as you can so that you can get a new image. And what we say about these two shapes, the original function and the new function, is that they're congruent. Okay, which basically means that they're the exact same size. Only thing that's happened is they've been again translated, which means they've been shifted. Okay, so again, shifted horizontally and shifted vertically. Okay, now the next type of question you'll get is where they give you an existing graph and the equation. And so same idea. You want to basically move this around. So there's your original y equals x squared. So here let's look at this equation. so what does this mean? So x, so remember this, the thing you got to be careful with is that sign in front of the h value. Remember, it's always opposite. So when you see x plus 2, what that's telling you is this is going to be left 2 units. Okay, and then the minus 3, that tells you it's going to be down 3. Okay, so so you can do this visually, or you can use the mapping technique. Okay, so the mapping technique means that you take existing coordinates and then you come up with the new coordinates, right? So for example, if I've got 0, 0, okay, so there's one coordinate, that's the vertex. That's going to get shifted, so left 2, so that's minus 2, and that's going to be minus 3. Okay, so minus 2, minus 3, so here's your new vertex. Okay, let's take this point here. That point is 2, 4. So we go left 2, so that's going to become 0. And then we go down 3, so that's going to become 1. Okay, so 0, 1, so here's another coordinate. Okay, here's another coordinate over here, negative 2 and 4. So that's going to become negative 4 and 1. Okay, so negative 4, 1. Okay, so there's 3 coordinates, and now we can draw the object here. Okay, and there's your translated image. Now, sometimes the type of questions you get, they won't really be recognizable functions. So, like for example, here. So, what's happening here is the existing graph that we have. We're calling that fx. Okay, so let's call this. Okay, so this one here, this is going to be our fx. Okay, so it's a weird looking function there. Now what we want to do is we've got two translated functions that we want to put on the same graph, same grid. So gx and h of x. Okay, so g of x is saying it's f of x plus 3. Okay, so what we'll do is we'll do a couple of mappings. Now, what I want to do first is let's find some coordinates from the existing function that we have here. Okay, so and we can label these. Okay, so let's call this A, B, and C. Okay, so those are 3 points that we can use, and basically what we'll want to do is we'll want to move those. So for fx, okay, so A, B, and C. Okay, so A is negative 6 and negative 4. B is negative 3 and 2. And C is 2, 2. Okay, so let's do the gx first. Okay, we can do, let's do that in red. Okay, so gx. Okay, so what this is saying is fx plus 3. What that's saying is we're not going to shift it horizontally. We're only going to shift it vertically. So all your y points are going to go down, are going to go up by 3. All your x points are going to remain the same. So when we do the mapping, all our x points are going to be exactly the same. So negative 6, negative 3, and 2. Okay, so those stay the same. Our y point is going to go up by 3, so plus 3. So negative 4 becomes negative 1. 2 becomes 5. And this one's 5 as well. Okay, and so now what we can do is we can put in those points for g of x. So negative 6 minus 1, negative 3, positive 5, and positive 2, positive 5. Okay, and so this is our gx. Okay, and then we can do the same thing for h of x. Okay, so let's use the same ABCs for fx. Okay, and so now let's look at hx. Okay, so what's going to happen here is our x values, so it's x plus 2. Okay, so that means we're going to go, this is going to be not to the right. So again, don't be confused by that plus. It's always the opposite sign. This is going to mean it's going to be 2 to the left. Okay, so that means all our x values, it's going to be minus 2. Okay, so the first one here, negative 6, that's going to become negative 8. Negative 3 is going to become negative 5. And 2 is going to become 0. Okay, so that takes care of our x values, and then the y values is going to be down 4. So negative 4 is going to become negative 8. 2 is going to become negative 2. Okay, so there's the new coordinates for hx, and then the same thing. Let's draw them out. So negative 8, negative 8, negative 5, negative 2, and 0, negative 2. Okay, and there's our hx. Okay. Now, ideally, especially when you're working with lines, you'd better to use a ruler. I'm kind of just doing a freehand, so I'm not being 100% accurate. But these are just sketches, so it's okay. So again, there's a couple of ways to do this. So transformation is basically an alteration of the original function, and when we say translation, what we're saying is it's a type of transformation that just involves shifting the existing function, so left, right, or up, down. The result of when you only do a translation is the result is a congruent function, which means it's the same exact size. Okay, it's just been moved horizontally and vertically. If you're able to do this sort of visually, that's fine. I find, especially when you get to more complicated types of functions, I personally like the mapping technique, which takes original coordinates and then produces image points, new coordinates that have taken into account the movement that you're doing. Okay, so I sort of like that method. Okay, so I'll stop here. So just look for the indicated questions that I'd like you to do, and then just as you're going through those questions, and if you're having any difficulty, just let me know and I can help you with that. Okay, so I'll stop here for this first lesson.